Now comes this question, grade 10 electrical circuits. The question says, consider the circuit below. So this is the circuit, and it says calculate the total resistance of the circuit. Okay, when you analyze the circuit, you have this 4 ohm of this parallel network, you have this 3 ohm resistor, and then what are we supposed to do to calculate the total resistance? So this is what you have to know from this arrangement, that the resistance total or total resistance, we start with this one, is equal to RS. Then we come to this one, which is equal to RP, then plus this one, which is RS. So because we have 2 S's, this one is going to be RS1, and this is going to be RS2. Yeah, RS meaning resistor in series, and RP standing for resistors in parallel. So what do we do under this circumstance? We can substitute for what we know. We say RT is equal to RS1, which is 4 ohm. Then RP, we don't know it now, but RS2 is 3. Okay, so what do we do under this circumstance? We can't proceed until we have got RP. So we go for calculation of resistors in parallel. So we say 1 over RP is equal to 1 over R1 plus 1 over R2. So 1 over RP is equal to 1 over 3 plus 1 over 4. Giving you 7 over 12. But you have to remember that we are calculating RP, not 1 over RP. So, but we know that 1 over RP is equal to 7 over 12, meaning that RP is equal to 12 over 7, giving you 1.71 ohm. So we can now come and substitute in here, and we say RT is equal to 4 plus 1.71 plus 3, giving you 8.71 ohm. So now comes this question. It says that using the equation V is equal to IR, calculate ammeter reading A. How do you go about this? Okay, this is what you have to know. We are looking for I, and A reads I total. But we know V total is the same as V terminal, which is 12 volts. And we know R total, we just found it as 8.71. So with this information, what do? We have the equation already, which is V equals to IR. And V, you can say VT is equal to IT RT. What is VT? 12. What is IT? Wanted times 8.71. So from here, what do? We simplify. And we say 12 is equal to 8.71 IT. So what do? We calculate IT, which is going to be equal to 12 over 8.71. Yeah, so giving you 1.38 ampere. Yeah. So comes this question saying calculate voltmeter reading V1. So this happens to be our V1. And I need to tell you that what we observe here is that current passes through our 4 ohm resistor. We have to remember that no current passes through the voltmeter. So it comes down like that. So from that, what do we get? We know the current which goes through V1, and that's the total current which we just calculated as 1.38 ampere. What else do we know? We know the resistor we are concerned with. It is 4 ohm resistor. And we are calculating V1. So with that information, what do? We equate the equation saying V is equal to IR, where V1 in this case is equal to I, which is 1.38, times R, which is 4. Giving you 5.51 volts. Yeah, so then comes this question saying calculate the voltmeter reading V2. Okay, and how do you go about this? You have to remember that the formula we are using is V equals to IR. But we need to know that we are looking for V2. It's what we don't know. But what do we know? We know I. If we trace this current, the one which passed through the ammeter, which is 1.38 ampere, passed through the 4 ohm resistor. It reached this junction. It divided into 2. It reached this junction. It recombined and proceeded. Here we have to remember that there's no current which goes through voltmeter because of its high resistance. So all the current which comes out of this branch goes through the 3 ohm resistor. So which means that the current is known and is 1.38 ampere. Then what else do we know? We know the resistor we are dealing with, and it is 3 ohm. So what do we do under this circumstance? We substitute. We are going to say V2 is equal to I, which is 1.38, times R, which is 3, giving you 4.14 V. That is it. Yeah, so comes this question saying calculate the potential difference across the parallel resistor. This is the parallel resistor we are talking about. Okay? And how do you go about that? So, to answer that question, there are two approaches. Both of them are okay. Let us try to use method one. Method one simply says that V terminal, which you call V total, is spread all over these resistors. So that one leads us to this equation that V terminal is equal to V1, implying the PD across here, plus VP, implying the PD across the parallel network, plus V2. And VT is known, it is 12 volts. V1, we calculated it as 5.51. VP, we don't know it, but we calculated V2 as 4.14. So from here, what do? We simplify and say 12 volts is equal to, so giving you this. So from here, we can confidently say that VP is equal to 12 minus 9.65, giving you 2.35 volts. So then we go to method two. In method two, we are going to use the equation which says that V is equal to IR, but we are calculating VP, so VP is equal to I total R P. So when you come to substitute here, we are going to get VP, giving IT, we know it, the total current which is flowing through the circuit, and it is 1.38. Then RP, we found it as 1.71. This gives us VP as 2.36 volts. So you have two choices here. You can use method one or method two. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yes, like we always do, we urge you to subscribe, to comment, to like, to share. And also to remind you that PSSB, Physical Sciences Silver Bullet, is a science YouTube channel specializing in physical sciences grade 12, 11 and 10, and natural sciences grade 8 and 9. Like we always do, we advise you to make use of our playlist Yeah, for grade 10, just go to playlist and place grade 10. All the materials for grade 10 will just come out. This is a guarantee. We mean all. So make use of that so that you don't have to check every video which does not belong to your level. With that, I can say bye-bye. See you next time. Stick with us. We believe we are the best. Bye. See you then.